Hello, welcome to my Fluent Project 3 test video tutorial. For this assignment, you'll need one constant density value and five different viscosity values, depending on what route number you choose from. Let's begin. Here's our mesh. So next on my checklist. Quick tip right now. Make sure you save throughout your assignment so you don't lose anything in case something crashes or goes wrong. Update. Double precision. SQS. We're gonna change that to K epsilon, standard, enhanced, all treatment, pressure gradients affected. It's not going 671. Okay. Materials. Fluid will be air, like always. We're going to change the density to 1.2. So for the viscosity, for each test, we have to make a Reynolds number to fit the description of what's provided on those tests. So in order to do that, he's basically use the Reynolds number formula, enter the constants, and then you'll get a new viscosity value, and you'll just plug it in here. Hit close. Then, oh, oops, I missed a step. Air fluid. We're gonna change this to 1, create and save. Change, create, and close. Otherwise, make this 1.2 again. Change, create, then close. And it should save. Go down to our boundary conditions. So my velocity, we're gonna just make it 5 meters per second. Hit apply. Everything else. Okay. Then we go to let's do the reference values. Reference values. For reference values, make sure everything's right. We're computing from the inlet reference zone. Shit. Ooh, excuse me. So for the area will be the area of the circle area here, which is basically pi r squared. Reference zone, surface body, control, methods, those all stay the same. Initialization, initialize. We don't need to see that. Run calculation, number of iterations. We're gonna make this 1,000. And calculate. Going by really slow because my computer is older. It's going. Calculation done. We're gonna go to our reports here. Click on forces. Select the wall. Print. And close. These are your pressure values down here and coefficients that you'll need later on in the project. Go back here. Now we're gonna go down to results. This is where you'll get your contours and stuff you'll need for the results. Let's let this load up. It's out the way. Let's start with the first contour. We're gonna go contour. Correct, sure. Okay. Location, symmetry 1, pressure. This out the way so I can see. Number of contour 110. Right. This here's the guide or rigid or legend, that's the word. Now, to make this look neater, we're gonna make this smaller. Whereas over here, so it's side by side with each other. We're gonna do contours again, this time for velocity. Now domains, location, symmetry 1, variable, regular velocity, number of contours, 110 again, apply, take this off. This is what the velocity should look like. You know, now we need some non vector velocity. And then we'll save again. Something. Now for the rest of them, you basically just have to change the value of the viscosity for each sample or test you do. We're just gonna come back. We're just gonna come back here. Go back to the fluid section here. So for my next test, at the same time I calculate these beforehand. For the next test, we're gonna change the viscosity to our new value. Change, create, close. Go back to initialization, initialize, and to initialize, go to run calculation. Initialization basically resets the whole calculation part again. However, this time it shouldn't take so long. And once again, you'll go back to report, click on forces again, and get your new values. So after you do that, you'll have to go back to the results tab and do a refresh. After you do the refresh, you'll notice there'll be a change in your data right here. And you'll basically just repeat this process 3 more times. Take screenshots of your contours and pressures, and then you'll use the data collected for your pressure forces and your coefficients. To make it look nicer, you want to put them into like say an Excel sheet and make a table out of it and make it look nicer, easier to read. Like for example, I'll show you over here. You should have something like this. And that's how I did the project. Thank you.